Dear students, welcome to second lecture of week number 4 to ECS 721 Data Structures and Algorithm. And the agenda for today's lecture goes as follows. First, we'll talk about introduction to stack data structure. Then we'll talk about its operations, push operation, pop operation, underflow, overflow, and some of them I have not listed here, but I'm going to go through also. Then we are going to look at two different implementations using arrays and using linked list. And at the end, we are going to present the overview of where a stack data structure can be used. So let's dive into the lecture. So a stack is a data structure that is based on last in first out. That means LIFO. So operations are performed in a particular way, and the element we insert last will be the first to be removed from the stack. And the reason for that is that it is one-ended. There is only one end of the stack at which we insert and delete elements. So a stack is one-ended data structure, and that end is usually represented as the top of the stack. So element can be inserted on top and can be removed from top, but nowhere else in the stack. So let's see some real world example. The first is the stack of books. So if you put books on top of one another, we call this as a stack of books. And now the last book that you put on top is the first to be removed if you want to remove it from the top. Similarly, we have stack of plates, and if you want to remove a plate, usually you are going to go from the top and remove the plate from the top, and then the second, and then the third, and then the fourth. So the first plate you put will be the last to be removed from the stack. So based on the principle of last in, first out. So let's say see the behavior of a stack data structure, that how elements are inserted, I mean push, and how elements are removed, I mean pop. So this is a stack, and there is only one end, which is usually represented by a marker or a sort of variable or a pointer we call top of the stack. And there is nothing in the stack at the moment. So we want to push a book of English, for example. We will push that book, and the top of the stack will be pointing to the top element on the stack. So if you want to insert another book of mathematics, it has to go on top of the stack. And this particular marker, or we would say it's a pointer which points to the top of the stack, will be updated when we push more and more elements. So let's push the mathematics books on top of the stack, and as you can see, the top pointer has been updated, and now it points to the top element of the stack. Similarly, if you want to put a computer book on this particular stack of books, we can push that particular book on top of the stack, and the top pointer is updated again. And if you want to push Islamic study book on top of the stack, and the top pointer has been updated, and this is how the push operation works. So it means internally in the stack, we need to have a sort of marker or a pointer which always point to the top of the stack, and it has to be remembered, because in the implementation we're going to do exactly that. And at this moment the stack is full, and if we want to remove an item, which is called the pop operation, we have to remove the element from top of the stack. So if we want to go back, for example, this is overflow occurred, and now if I want to remove from the stack the last element we inserted, it has been removed, Islamic studies. Now if we want to remove again from the stack, can you guess which book has to be removed? Yeah, the computer book, right? So the computer book has been removed, and observe the behavior of the top, that it's been now decremented, right? So similarly, we can pop the mathematics books, and once we pop the last element of the stack is called empty, and we can say that an underflow has occurred. So that's how the stack works. Let me go back. So what are the different operations? The push operation means insert an item on top of the stack, right? So there is only one end, which we call the top of the stack, and whenever we want to insert an item, it has to go to the top. Similarly, the pop operation removes an item from the top of the stack. So as I said in the introduction, that the stack has only one end, and that end is called top of the stack. And if you want to remove or insert an item, it has to be performed on the top of the stack. Similarly, we have a peek operation which returns whatever the top value of the stack is, but it doesn't remove it from the stack. And remember, it's a very important point. The difference between the pop and the peek is that pop removes an item from the top of the stack. It no longer is in the stack, but peek just returns the top value and it doesn't remove it. It still exists on top of the stack. There is another operation called empty operation, or sometimes called underflow in the terminology of data structure. That means check to see if the stack is empty. So if the stack is empty, there is nothing to pop more, and this is called an underflow has occurred. Similarly, we have the full operation, which checks to see if the stack is full. And we have this operation only in the array implementation. As we talked about in the linked list, that linked list can grow dynamically and you can acquire more memory from the heap. So there is no such thing as full operation in the implementation of stack using linked list. Now let's see the code that how can we implement the stack. So one way to implement a stack is using arrays, and stack class encapsulate arrays internally to store items. And of course, arrays of fixed size, so the stack will have the full member function, which will return true in case if there is no more space. In the linked list implementation, the stack class encapsulate a linked list internally to store items. That means we will have a structure called node or a linked node, and we will be creating new nodes, and we will have a pointer which will point to the top of the stack. The size is of course dynamic and doesn't require any copy operation at all, as it happens in arrays implementation, because if your stack is full and you want to resize the array, you will have to copy the old elements from the old array and create a new array and then point to this new array. But of course, we have the linked list. So both these two implementation has its own pros and cons, and we'll look at them later. So let's take a look at the implementation using arrays. So we will call this array stack, for example, but the concept is that we want to have three data members in our class. One is called the top, and remember in the simulation I mentioned that there will be a marker, and in this case we are going to call that the top, and the top integer will always be pointing to the top of the stack. We have a list pointer, and this pointer will be pointing to an array that we create on the heap using the new operator, and as you can see here in the constructor. And we have a capacity which will be the maximum number of elements we can store in the stack. So now let's talk about this default constructor. We'll give the stack class a default constructor which does initialization, and in particular it has to initialize the capacity to 5. You could initialize the capacity to some other integer variable. I have done this because for a simplicity reason. And we have created an array on the heap based on that capacity and return the pointer of that array, and list is actually pointing to that first location of the array on the heap. We have also initialized the top of the stack to -1 because we are using arrays, and a valid invalid index for the array is going to be -1. We could have initialized the top to 0, but I'm going to explain that why I've initialized it to -1. And the data members remain the same. We are also going to give our array stack class an overloaded constructor. And an overloaded constructor is a constructor which takes some arguments from the client code and does something based on that argument. So we have a capacity variable as a data member, and the user has to provide the initial capacity for the stack, and we are going to assign that value to the capacity. So again, these two lines are the same as for the default constructor. But the important thing here is that this stack constructor now takes an integer argument, and when the client provides a value at the time of creating the object of this particular class stack, then we have to initialize the capacity with the client provided value. The push member function is one of the most important function of the stack, and these names, by the way, push and pop, are conventions in computer science So this push operation, if you remember, pushes an element on top of the stack. So initially the value of the top will be -1 in the constructor, if you can see here, and also in the default constructor. So whenever we want to push an item, we have to first increment the value of the top by 1, because -1 is not a valid index when we are implementing stack using arrays. So we have to update the value of the top by 1, which means it becomes 0. So top value was -1, we add 1 to it and it becomes 0 now, which is the first index of the array. And then we have to assign the element to the first index of the list. And if we call the push member function again for the second value, again we have to increment the value of the top so that it points to the second index of the array, and then on that second index we are providing the next value. And this, if we call the push member function again and again, and this will have to do exactly the same thing. Now let's talk about the pop member function, and we talked about it in the member function section of this presentation, that it is a member function. When it is called by the client, it has to return the top value, right? And it's also have to remove it from the stack, because the difference between the pop and the peek that we are gonna look at next is that peek does not remove the item from the top of the stack, but rather just returns the value. It's like to see what's the top value, but pop removes it from the stack, and that value will no longer be on top of the stack. So first we have to store the top value in some temporary variable, and then after that we have to decrement the value of the top. That's where the removal part comes, and then we return the temp value, which is the value on top. Similarly, we have a peek member function, and it does just what it says. It's going to peek and return the value, whatever value is on top of the stack. So list bracket top means that top is pointing to the top value, and we are simply returning that value, but we are not removing it from the stack. The empty member function, also called under flow, it is a member function. When the client calls this member function, it's gonna check to see if the stack contains any items. So if the top value is -1, that means the stack is empty and there is no element in the stack, and it returns true because the return type of this function is true, and this equality operator returns true if it holds for these two operands, and if the top is not equal to -1, then it will return false. So when we call the empty member function, it's going to return true if it's empty and return false if it is not empty. Similarly, we have the full member function, because we are implementing the stack using arrays, and array are of fixed size. So if the value of the top is equal to the capacity, and remember that the capacity indicates the maximum number of elements you can store in the stack. So if the capacity is equal to the top value, that means the stack is full and there is no more space for new items. The print member function is, there is a little bit of problem here, but I'm going to explain that in the code. It's simply going to traverse the stack in the last in first out manner, and it's not going to remove anything from the stack. So it's just a for loop, and we are actually retrieving elements. But because the behavior of the stack is that the last element should be removed first, this code I didn't check before is not doing exactly that, because it's doing the opposite. It's returning the first value of the array and then the second and the third. We are going to actually do the reverse process. So I'm going to correct this code in the implementation section. The get size member function is, I usually give this function to almost all data structure. If the client needs to know what is the current size of the stack, it can just call this get size member function, and it's going to return an integer value indicating the current number of elements in the stack.